I will shut off the lights while we're doing these notes so everybody can see. It makes it a little easier. Okay. So there is a difference between direct variation and inverse variation or indirect variation, right? Direct variation, we said yesterday, was y equals what?
K.
Y equals k times x. So if direct is k times x, what do you think inverse is going to be?
K divided by x.
Woo! Equals k divided by x. Okay? K divided by x. And I'm sure that's my recycling. It's right here behind the door, friend. Thank you.
I want to get that job.
Okay. So, at the top, your equation for direct variation, so we can review it, is y equals k times x. Okay. Your graph was a what? A line. Okay. Your line always went through the origin. So we had a line that would look like this. And this is when k is greater than 0. When you had a positive slope. Or my graph could have looked like this, which means k was less than 0. Bless you. So those were the two graphs we looked at yesterday. Okay. We said it always went through the origin. Okay. Inverse variation, we said was y equals k divided by x. I want you to take a look at that for a minute. Okay. There was something that you should have learned that we can never divide by. What's that number? 0. We can never divide by 0. So in this equation, x can never equal 0. Okay? Because I can never divide by 0.
One of them dirty towels. I don't know what they call them.
Terrible towels? Yeah. I got a rep.
You went to a game?
Did I go to a game?
Yeah.
Several times. You realize I'm from Pittsburgh, right?
You got money like that?
Huh?
You got money like that?
I've been to like probably 7 or 8 games.
Serious?
How many times have they won in each game you went?
No, I don't remember. Okay, the graphs in inverse variation, okay? Just like we had in direct, if k is greater than 0, my graph looks like this. It kind of splits into 2 pieces. Notice, it doesn't touch the y-axis, and it doesn't touch the x-axis. Y will never be 0. X will never be 0. So these are what we call asymptotes. Okay. You will get more into that in Math 3. Okay. If I flip this and reverse it and make it k is less than 0, that flips my graph. So this one on the left that would curve down is now up here and it curves up. And the graph that was normally up here in the first quadrant goes down here in the fourth quadrant. Questions? All right. You flip the page. we need to look at each one of these equations and tell me, is it direct variation? Is it inverse variation? Or is this neither? Okay. Now we know the difference between direct and indirect. And then we can also say, no, it's neither one of them. So before I can do anything, my equation must be equal to y first.
This first one is neither.
The first one is not equal to y. So I can't determine anything until I make it equal to y. So how do I get this equal to y first?
Four actually.
No. I need to get the y out of the bottom first. Multiply by,
-4.
thank you. We multiplied by y. I need to get rid
I said that first. And you was like,
of,
Yeah, you kind of did look at it when you said that crazy.
I wasn't looking at you. There are people behind you. Hi, Jeremiah. Okay. I was trying to get rid of the people that are sitting here going, -4. If I multiply this by -4, it turns it into -16 or +16.
that's because
What does
four is
that
the number.
fix? It doesn't fix anything. Okay, so you can look at this one of two ways. I can multiply both sides by y, or the same thing as putting this over 1 and cross multiplying. Because then that makes this x times y equals -4. Okay, so either way works. I can multiply both sides by y, or I can put a x over 1 and cross multiply. Now I need to get y by itself. So what do I have to get rid of? Divide by x.
Times y.
It's times y.
Oh my gosh, it works.
And oh my gosh, y equals -4 divided by x. So what is this? This is inverse.
Oh.
Okay, this one's inverse. And we can't write yes anymore because we know about direct. Okay, so you have to tell me it's inverse, direct, or neither. Take a look at number 2.
That's neat.
Neither.
That's neither. What makes this one neither? That -2. Yes, ma'am. With what?
Like I've got it all down and like I got where you're at, but what makes why is it?
Because the k value is divided by x. Okay. So if the k value is multiplied by x when it's equal to y with nothing added or subtracted, it's direct. And if it's divided, it's inverse. Okay. So you said 2 was neither because why again?
There's a y-intercept.
There's a y-intercept that's not 0. This one doesn't go through the origin. So this one's neither. And if you need to put a reason, it doesn't go through the origin.
How can you tell it doesn't go through?
Because it has, remember, this is y equals mx plus b. So -2. So this line actually goes through -2. So if I would graph this one, Mo, it would look like it would go down here and then go up. So it doesn't go through the origin because of my y-intercept. Okay, good question. Number 3. Again, it needs to be equal to y first. So I need to do what? Divide by x. So y equals 6 over x. This one should be inverse. Number 4 is already equal to y. This is what? Direct. Okay, this one's direct.
And K equals 8.
And k would equal 8, absolutely. All right. We need to be able to write equations, just like we did with direct variation. Blow this up a little bit. A lot of it. There we go. Woo! Now, if you can't see this, you definitely need to get some glasses. So, just like yesterday when I said, if it says the variables vary directly, you automatically write this equation down. Same thing happens here. The variables x and y vary inversely. So that means I write y equals k divided by x. It varies inversely. Okay, that automatically tells you y equals k divided by x. So now it tells you y is 5 and x is -2. I need to find my k value then and then write my equation. So if y is 5, this becomes 5 equals k divided by my x, so it's -2.
Tom, -2.
Multiply both sides by -2 to solve for k. So k should equal -10. Who had their hand up? You just wanted to answer? Okay. I just wanted to make sure you didn't have a question. Okay, so now that we know that k is -10, you have to give me the actual equation. So my final answer should be y equals -10. Whoops, that shouldn't be y. Divided by x. There's my equation. Okay. Once you get the equation, I can then tell you x is 5, and you could solve for y. Or I could tell you y is 2, and you could solve for x. Okay. Your goal, though, is to get that equation first and then use it from there. Okay. All right. We scoot over. The variables x and y vary inversely. So again, we start with y equals k divided by x. This time my y value is 9 and my x value is 5. Multiply by 5, which gives me my k value of? Beautiful. So I multiplied by 5 on both sides. So then my equation is y equals 45 divided by x. I can do the same thing from a table. So yesterday, when we did direct variation, to get my k value from a table, we did what?
Divide y from x.
We did y divided by x.
So you do y times.
Oh, so now we do y times x to see if they're all the same. So if I multiply -5 times 4, -20, -4 times 5, 1 times -20. Woo! -20, -20. So that tells you that this is inverse, because when I multiply the values, they're all the same. They have all that same k value. So my equation is y equals -20 divided by x.
Oopsie.
Oops, she dropped it again.
Oh my god. Oh, it's perfect. I love that Amy. Right?
You and me both, my friend.
All
right. This one, 6 times 2 is?
Wow.
5 times 2.4 is?
Wow.
4 times 3 is?
Wow.
3 times 4 is?
Wow.
2 times 6 is? Whoa!
Y equals 5 divided by x.
Oh, you guys crack me up.
I'll be your favorite.
Two hips.
Always.
Like, I call myself that for skinny people like you don't do it behind my back. Now that part right there. I'm tight, so.
All right. Last one. How on earth do I graph these?
Run for run? Or no?
Okay. So
What is this?
I'm going to tell you this. We're going to do this, but guess what?
The calculator.
The calculator graphs it for you.
Yeah.
Okay. So you're mainly going to use your calculator to do this, but we're going to talk about it anyway. Okay. So the shape of this graph is called a hyperbola. And it looks like hyperbola. Called a hyperbola. And no, it is not
I believe.
Ebola.
That's messed up.
Okay.
Did they just run out of words?
Oh, it's like
Make
the-
some up.
It's like the intense version of
They
the
said terrible.
Hyperbola.
Okay. Because there's two separate pieces. These are called the branches of your hyperbola. And they are two symmetrical parts. Okay. So in other words, if I fold my paper at the origin diagonally, my parts should lay on top of each other. Okay. It's like a reflection across your vertical asymptote. And like I said, the asymptotes of the hyperbola are the lines that it will approach, but it does not intersect. Okay, so graph the inverse variation equation. Inversely, this should be y equals what?
8 divided by x.
8 divided by x. Y equals 8 divided by x. So, you know it's very hard to graph decimals. So I try to come up with some numbers that actually give me whole numbers. So, I can divide 8 by 1. What's 8 divided by 1? 8. 1, 2, 3, 4, 5, 6, 7, 8. So that means I have a point at 1, 8. I can divide 8 by 2. So that means my next point's going to be at 2, 4. 1, 2, 3, 4. What else is 8 divisible by? 4. And that gives me
4,
2. 3, 4, 2. Give me one more. 8. I kind of ran out of room here. 8, 1. Okay, so here's this top part. Okay. Don't forget though, this should have 2 pieces to it. So we went the positive way along x. I can also go the negative way. So if I make positive 1, negative 1, what's that change my 8 to? Negative 8. Oh, yes. Okay. So this is a reflection over that line y equals x. Or I'm sorry, y equals negative x, not y equals x. Okay. So when I change the sign of the left, I also change the sign of the right piece. So I also have a point at -2, -4. I have a point at -4, -2. And I have a point at -8, -1. And that gives you this side of your graph.
So we always abide by those numbers?
I always pick numbers that will give me whole numbers because they're easier to graph.
But we really
So like
have-
I could do 8 divided by 3, but that's going to give me a decimal that's hard to graph. So I specifically pick numbers that are easy to put on the coordinate plane. Okay.
Usually we won't have to do this, just calculate.
Right.
Okay.
Okay. So this one should be y equals -6 divided by x. So again, -6 is divisible by 1, and that leaves me with -6. So 1, -6. 3, 4, 5, 6. What else is -6 divisible by? 2, comma, -3. 3. Whoops, I counted wrong. Not that one. This one. 3 and -2. Good, Kenzie. She's up here whispering so softly. 3, -2. And one more. And I can do 6 and -1. Okay. And then you do the opposite of it to graph the other part. So if I had one at 1, -6, I've got one at -1, +6. If I had one at 2, -3, I've got one at -2, +3. And I have one at -3, +2. And -6, +1. Excellent. Notice the graph in the left one was up in the first quadrant and down in the third quadrant. Now it flipped and it's in the second quadrant and the fourth quadrant. What do you think did that?
The -6.
The -6. Because that 6 is negative, it caused it to jump quadrants.
Smart stuff.
Yes. You're tired. All right. Sorry that you're tired, but we've got 2 more to do. Okay. So, y equals 5 divided by x. So, I've got points at 1, comma, 5, or 5. Is there any other pretty numbers that 5 is divisible by besides 5? No. So this one we're going to it's going to be a little bit off because I only like pretty numbers. But I mean, we could do, okay, let's do, hold on. I can do 2, and that's 2.5. That one's not too bad. Okay. I can do 2 and 2.5. So 2 and 2.5, that's here. 2.5 is not that bad. You're right. Brandon's like, would you just do the extra work? Come on now.
I don't want to do it.
Just because he's lazy doesn't mean he's not smart.
Yeah, we didn't say he wasn't smart. We said that he didn't want to do it.
You're right. He doesn't want to do a lot, but we still love him.
Look, I don't even want to come in, but I'll get in trouble if I go to school.
Right. Well,
You want to see our beautiful faces in the morning.
No.
Yes. You love my face.
I'd rather sleep.
Oh.
It is
Okay.
like-
If school wasn't mandatory, I don't think I would go.
Me,
Oh.
I think I'd go on again, though.
Don't forget two, because I've got another piece. I just reversed my sign. So I've got one at -1, -5. I've got one at -5, -1. And I'll have one at -2, -2.5. Number 12.
Oh, no.
1 and
-9.
-9. 3 and -3. And 9 and -1. So look, these all go by threes. So be careful when you graph it. 1, -9 is somewhere like right here. 3, -3 then is going to be right here. And 9, -1 is going to be somewhere right in here. They didn't want to extend the graph and make it bigger, so they just changed your...
Crazy.
They hate us.
Okay. Then I can always switch it. -1 and +9. -3 and +3. And -9 and +1. So -1, +9. -3, +3. And -9, +1. Okay. Before you flip this off, you can just set it over there, Miss. Thank you. It is. It's all my copies I needed made till Thanksgiving for my 34th walk. Because Marissa's awesome like that. Okay.
I know
So,
she gets
one thing I want to talk about before we glue this in, and this really has nothing to do with graphing or solving inverse, but y equals 1 over
Do we have to write this?
x minus 2. Yes, please put this in your notes. Right below it, it's fine. We're only going to do 2 and talk about them. Y equals 1 divided by x minus 2.
He has a plug.
I know that's the right.
What was that, Brandon?
I know that's the right.
Yes.
The other one you said was subtracting this one, right?
Look where my minus 2 is. Okay? It's with my x. Okay? So just like when we did quadratics, and if it was inside the parentheses with the x, it moved it left or right. Or we did radicals, and if it was underneath the radical with the x, it moved it left or right. If it's with the x, it moves left or right. And it always goes opposite. So because this is x minus 2, this would move to the right by 2. What if I did y equals 1 over x minus 3?
No. That
Is
will
it
go
with
down 3.
my x anymore?
Down 3.
No, it's on the outside, so it affects how it moves up and down. So Mo is absolutely correct. This one would move it down by 3. Okay, so please understand these transformation rules, they apply to every equation that you do. Okay, that's never going to change. So next year when you get into absolute value functions, these rules apply. They're never going to change. Okay. Question.
Mom always said that she wasn't
It goes
going
down whenever you.
Huh? No, it's the same. The y's are always the same, the x's are always opposite. Okay.
My mom said she want to go back to reading, writing, arithmetic.
Read, writing, and arithmetic. Why? Because algebra was too hard.
Because she doesn't like this kind of math.